OK, hello everyone, and welcome to the cables.gl workshop at the Assembly Summer 2022. So, I'm Susanna Viljamaa, but you people might know me better as the Bass Cadet. And I've been pretty active on the demo scene, hanging around since the early 90s, and I've been using the Bass Cadet name since 1993. And I've been in several groups like Embassy and Muller's Phase T, doing some music over there, Promel Design, Adapt, OOBC, and Proxima Centauri, which is a new school demo group. And I've been a pretty active visitor at Assembly since 1994, and I've been organizing the Assembly since 2009. And my interests span across the visual field and the audio. So I have been mostly doing music for demos, and people quite often know me about that, but I do other stuff as well. And I'm into direction of the demos and the visuals. And I'm just usually interested in coding for using as a tool to enhance my music or audio. And I'm also into hacking, and I was founding the Helsinki Hack Lab in 2009 when it was founded. And I used to be a self-taught professional developer for 13 years, although it's not something that I intended to be doing for work, but I ended up doing that. And I've been pretty interested in old school stuff, like I've been doing Commodore PET stuff in OOBC, and I want that to be developing into something that's more recognized. And the reasons why I like cables.gl. I have a pretty short attention span and thus a short temper. And I'm a lazy person, and I don't usually have that much of energy to try to set up stuff, and I like to do it easy and quick. And I'm also more of a designer person than a coder. I like that Cables is also pretty usable on mobile devices. Like, you can just check the QR code and open the stuff running on your mobile phone. And also, Cables is good for learning how things work under the hood. You don't need to be able to code when you start doing a patch. You can just do some 3D stuff and look how the shader code is built or how the JavaScript code works beneath that. For example, if you want to develop to be competing in the Shader Showdown finals at some year. And Cables is also completely free to use. And it's not designed to be a demo scene tool. It's a generic tool for creating real-time audiovisual content that might be also interactive. It could be used for installations and websites and any kind of stuff you can imagine. And you can have some input devices, human input devices, get stuff from camera, and fetch stuff from the net, and whatever you can imagine. And Cables also has a great community that is willing to help you as a person who's just starting to learn Cables. And you also get to communicate with the author, Pandur Hai, who has developed Cables. And he's also quite happy to fix the bugs that I have been finding if they're just manageable or not that big of a bug to fix, and also implement new features that people have requested. There are some reasons that I still don't like Cables at this point. For example, the thing I hate the most is the timeliner. And there is a tool to create the timeline and keyframes, but the usability could be improved a lot. There are a lot of quirks and bugs in the user interface, for example, and it would need better tools to construct that and manipulate the keys. And another thing is that if we want to create demos, in order to get the initial preload, audio and video sync, and autoplay to work properly with demos, needs some work and research to be done, or you can try to see how other people have done that, but sometimes these workarounds don't work anymore. For example, if browsers have changed, like nowadays, they require some human interaction to unmute the sound. You have to click the unmute button, and one problem is that there's no sync anymore if you hit that later on after the demo has started. But I'm going to be introducing stuff or workarounds how to do that, and post some prototype patches that you can start to write your own demo with. And the third problem is that much of the documentation is just videos on YouTube, and I would like to have a quicker way of learning things, like reading stuff, than watching a video that might be half an hour long, just to notice that it doesn't tell what I need to do. And sometimes the operators are documented in theory, but quite often the inputs and outputs are not explained what they do. And if the operator is lacking an example patch, it might be difficult to understand. But that's the thing that I try to develop cables to be a little better in that sense. But it takes time. And when you compare cables to other options like Godot or Unreal Engine and so on, you don't need any additional software installed on a computer. You just need a web browser, and that is all you need on your computer. And the user interface is quite intuitive for me as a visual person. You just see flow charts that are interconnected and stuff happens there, and you get a clear visual look of what happens there. And I think I did already said about you don't need to write necessarily any code at all with cables. But whenever you want, you can just open up the hood and watch how it is done, how operators work, and so on. And also, the entire engine runs in a browser. But you can export the stuff outside so that it runs on the framework that runs it, Electron framework, so that it can work on a standalone executable. And also, everything that you do in cables is stored in the cloud. Nothing is stored on your computer. So you can just, every time when you save the patch, you can open it up in another device anywhere in the world. And the projects that I have done with cables is, for example, the demo Multiplier by Proxima Centauri. And it was the first time that I got it worked with cables. I used something between 1 and 2 weeks to learn the tool and write the demo that won the competition. And I'm not going to be showing it now because it takes time. And I have done some websites that use cables, patches as backgrounds, like, for example, attractive.ai. That's a site that checks with an artificial intelligence that how your website is usable by artificial intelligence. And the stuff runs on the background is done on cables. It's a 3D scene, and the targets and the other stuff that move around here is done with cables. And for example, the Deep Dive's website has the background. There are some clouds that are coming over there. And this is done with cables. And also, the Meteor Awards ceremonies, Best Visuals category. Video, I did the background and the 3D effects with cables as well. So this is a patch that does that neon globe landscape and that sky and me blowing up and so on. Yeah. And yeah, and I did some promotional video visuals for the educational videos of Deep Dive's company that I used to work for their trailers. For example, there was an artificial intelligence course, and I did some stuff that visualizes that like these controls of user interface or something like that. And some work that I'm still not showing you because it's going to be on demos later on. But how should you start? Just go to cables.gl and register there. And if you have already been registered, just sign in. And you can access that with the QR code over here. Unfortunately, the editor isn't that usable with the mobile devices, but you can view the patches that are there with mobile devices. And usually you need a laptop or a desktop computer to use that effectively. And we just start to see how cables works. We can do the tour. Let's start the introduction. There's text that I don't know how readable it is, but in here is the area that is used for the stuff that's happening on the screen, like all the operators over there. It's this gray area over here. And the canvas that the user will see is on the top right-hand corner. This is a panel for several things, like editing keyframes, properties, and operators' properties, and editing code for specific operators, and so on. This is a tab selector for that panel. And the main menu for stuff like accessing the patch names and properties and sharing that stuff, and also exporting. And here is the sidebar menu, for example, saving the patch, adding a new operator, accessing the settings, and going full screen. And the documentation is in the question mark over there. So here it is. And also, if you're unaware of the keyboard shortcuts, you can access them in the keyboard shortcuts, and you can get them listed over here. So if we start with a basic patch, you always need the main loop. But before we go any further, we can just draw cables, and let's start a sequence. For example, we see that stuff is happening here. But I have another patch that explains what all of them do. And that's already public. And this is something that is good to see when you start learning cables. Also, I forgot to tell you that the timeline is over here, the tool that is a little quirky, and let's hide it over there because we don't need it right now. So the main loop is an operator that runs on every frame. And what it does is that it sends a trigger on every frame to the operators that are further from there. And the trigger signal is always yellow. And it does nothing else than send a trigger so that the operator does something. The green one, or the cyan one, is a number. So it's numeric data. And when you hover over it, you see that there's a time running out of that. It's a timer up that outputs a number of the time that this operator has been running. And then we have the transform that is moving and scaling and rotating stuff that comes after that. And here we see that scene that is consisting of cubes. And this timer is modulating the Y rotational axis of the transfer. So you can see that the incremental number is going there, because without that, it would be just, it would be just stationary. And we go further. Texture is the first one of the purple cables, and it's a little confusing that there are in total 3 different purple cables that you might mix up with each other. And the problem is that if you accidentally manage to pull wrong type of purple cable to another input, you might crash the patch and you have to reload that. But the first one is the texture. Here we have this kind of a droplet. And these cubes are quite metallic looking because they have the MatCap material new, which is using environmental map, if you know from the Damascene effects. And it's reflecting that image. If we remove that, they're just basic cubes that are flat shaded. So the texture goes to the MatCap texture input to the material. So objects need to have a material so that they have a look, because otherwise, without that, we basically just blank cubes there. And the next purple cable is the shader output. Materials generate shader, and right now this doesn't do anything specific, but you could, for example, if you're importing 3D objects that you have done, for example, in Blender, and they have specific materials, you can connect these materials to specific materials in the object there. And the third purple cable is the geometry. Every 3D object that is generated also generates a geometry output, and you can output that to another operator that takes advantage of it. For example, this mesh instancer is an operator that multiplies this single cube into a 100-fold set of cubes. And how it does that is that it has a set of arrays. These blue cables that are arrays, and unless you know what an array is that it's a set or a list of numbers. And for example, here we have a list of 100 numbers. So we have 100 cubes, but we need to access those as triplets, because in 3-dimensional space we have X, Y, and Z. So in total, there are 300 cube positions there, 300 vertex positions over there coming out. So in total, 300 numbers. And these are the positions. Also, we can set the rotations, like here. We can remove that, and they're all in the same rotation. We could set scale by random, or colors, or texture coordinates. But this is a simple set of mesh instancer use. And also, if you're interested how it works, you can get the shader info that comes up to this point. If you want to go coding shaders, you can check how that works, which kind of a scene does it generate, the fragment shader, vertex shader, and modules that it uses, uniforms, and state info. And the last cable type is the string, which is always red. And we use that for this number that is running, telling how long this patch has been running. And also we take the main loop, it's triggering the transform so that it's not in the center. And we have the relative time since the loading of the patch. So it generates a number that we want to round, because otherwise it would be filling up the screen with the digits. And then using a numbered string operator, which turns it into a string, which is generatable as a texture mesh over here. So we have the mesh viewable over here. And now you know the different cable types that you can use while generating patches. And we can leave this. And we can start doing our first own patch. So first we have the main loop. And we can generate a new operator by just clicking and dragging this. And let's start first. You can add operators by clicking this add up or hitting ESC and just typing something. You can add main loop that we need, and clicking and dragging and creating a new operator from that output. And let's say we would just want a torus because it's an easy and accessible shape and recognizable one. So we got a gray donut over there, and it's a pretty dull looking because it doesn't have any material. We can use, for example, Lambert material, which is pretty basic Phong material. We can access the parameters because this blue is generated by random and it's pretty dark. So we have let's try to find an edible shape, edible color for a donut. But it's pretty stationary there. We might want to make it a little smaller and looking more like a generic donut. So we have the donut, but it's stationary. What if we want some life to it? You can, at any time, you can click on a cable while there's a circle showing in front of it, and you can add an operator in between, like, for example, transform, which moves and rotates objects. So that's in between. And unless you're seeing that flowing movement, you can hit F key and set on the flow visualization. So you can see clearly what's happening there. And transform doesn't do anything by default, but we can move it, or scale it, or rotate it. But that's still manual. I have to manually alter these numbers, and that's not so usable for a demo. So one way is to add a timer. So that's an operator that I already told you about. It generates the time that it has been running. We can set it to rotate or position, but it already went out of screen. But when I set it on the rotation, it looks like it's not moving. But the thing is that it's only moving 1 degree per second, which is pretty slow. And if I set it to 90, we get a rotating donuts. And if you want to move a cable from an input or output to another one, you can just right-click and drag it onto another one. So now we have the rotating donuts. What if we want to, for example, make it bounce? We can add a new timer and set it generate input for an operator called LFO, which is low frequency oscillation that is good for animations. So we can make it, for example, wiggle. Let's disconnect the rotation because it makes it more distracting to understand how it works. We have the sine wave, the triangle, which is more linear, ramp up, which is always moving one direction, ramp down, and block, which is a pretty binary state of two positions. But I like the sine because it's easily convertible to bouncing. If I take the absolute value of the sine wave, so we have the bouncing donut that is rotating. But what if I want to have a floor over here? A good thing to do right here before doing anything else is to create a sequence. And right now it doesn't do anything, but it's a thing that makes things happen in the proper order. And we move it to the second one because we might want to do or create some texture for these objects at first before we are rendering the 3D stuff. So we add a floor, which is a rectangle. Oh, sorry, that was the wrong one. The rectangle. So that looks a little stupid at first. We have to transform it first so that it will be in the right, in the right angle. Yeah, this is a proper one. So, but it doesn't show because it's still flat in front of the camera. And now we have the floor, which could be a little bigger. Let's say to like 4 times bigger. And we still need the material for that. Oops, I did a mistake by clicking the pivot point. So now it's centered. Let's say I want to make a basic material. Oh, well, yeah, let's set a basic material. And now we create a texture that is dynamically generated. We need to create it first before the 3D stuff happens. And that can happen with the image compose. and then on. We can use, for example, plasma, or let's use checkerboard at first. It's quite simple, but the thing is that it's the same size as the canvas size, which is pretty, it's a little not that usable for a texture of an object. So what we do is that we take the image compose, and we know that the texture size is matched to automatically the canvas size. We can set it to manual, and I usually like to keep the textures in a square shape, and powers of 2 are quite usable for texture sizes so that they're more optimal in some devices. And now we have a square-shaped texture that we can use for the floor. You need to notice that image compose has a purple output, that is the texture out. You take that and drag it over to the basic material of the floor. Now we have the checkerboard floor. So now we have a basic scene with 2 objects, and before we go any further, it'd be handy to add a tool that is really valuable for checking out how things are. It's the orbit controls. So when it's in front of the other operators, you can just click and drag the scene to see how it looks from different angles. Or you can zoom with scrolling with the mouse, or with the right-click dragging, you're able to move the view. And you can always reset that view when we get lost. So we have a little mess over here. Let's move these a little more left. Yeah, that looks better. But one problem is that I would like that donut to be not going through the floor. And the thing is that these 2 timers are not synced because they were added at different times. And when we're doing demos, I like that the time is always in sync with the timeline. And there's an option for that in the timer operator, when you scroll further, that you can sync it to the timeline. So you see that now it's not moving anymore, it's stationary, because the timeline is not running. If I start the timeline or fast forward to any other position, it's always in the same phase. And what I would like to... Oh, something happened. Okay. What I would like to do is that I would like to set the decrease speed to be 180. So it's always facing flat side down. And if I want to be really specific, I can move the floor to be exactly on level with that. So it would be about half of the thickness of the toroid. So now it's not hitting through the floor anymore. So if we want to get a little more fancy, we can remove the Lambert material. Sorry? Oh, okay, yeah. Okay. Yeah. Okay, so we lost the visual because the cable got loose. We're working with cables, both software and physical cables, and anything can happen. So now I don't know how long you went without any signal. But anyway, here's the torus, and I like to make it a little more fancy. We were showing the Lambert material, which is the phosphated one, and basic, which is like always a flat or also always a certain shade. And we can use madcap material new, which is a simple material for generating metallic-like materials because it can do reflections, although they are fake. And it's a handy texture or material because you can convert it to flat shaded if you want to do that retro look. So you click the screen space normals and you have the flat shade. And also, at any point, you can access the files. You can upload files, or you can access the library files that are always usable in cables. And there's a set of images and HDR textures and some lookup tables and math caps that we use for this. And 3D models, music, and videos, and wipes. But now we want to have some metallic shape, or metallic material for that donut. And we take, for example, chrome, right, and pull it to the textures math cap. And now we have a chrome donut. And if we want to make the scene look a little better, we can make lights into that. And I just didn't think it thoroughly, but I should do another sequence so that I'm able to connect these things together after a certain set of things. And I would like to keep the lights on top of these all objects. For example, spotlight is a pretty usable light for the demonstration so that it has a certain position and a certain angle, or it's pointing a certain position. And we get a warning that no operator is using this light because one is basic material, and I think that the environment that map material isn't using it. So we can change the floor material. It's now basic material, which is always lit at full power. And we can use, for example, that Lambert material for this example. And now something weird happened. And this is a beginning mistake that you can run into. And the problem is that you're seeing the floor on the wrong side. It's rotating in the wrong way. And if you turn this the other way, the floor appears. Because now we're seeing the front face of that rectangle. You can have the problem with, for example, cubes, if you're inside a cube, and so on. And you can also flip those normals, so you can see the inside. So we take the checkerboard, and now we have a little shade towards the ground, towards the corners of the checkerboard. What if we want to have some shadows there? We can add the shadow operator to the floor. Actually, I think we could show one little handy thing of handling messy patches. We can select multiple operators and create an area. And we say that this is the floor. So that always moves as a group together. And we can move it a little further over there. And we can add the shadow operator. And this is a little funky operator because it needs to usually be in the proper phase over here. Usually after the material, but before the mesh. And now we have the warning that there are lights in the patch, but none of them cast shadows. So we need to check the cast shadow of the light. And there it is, the cast shadow. And we can see what the light sees, which is quite handy because not always do you see where the light is pointing or where it is standing when you're just looking at the target. And if we're moving the lights in the 3D space, you can see how it's positioned towards the scene over there. It's quite handy. And also, when we're editing the shadow operator, we have a set of different algorithms for the shadow. Because this is quite a harsh shadow with hard edges. We can have PCF or Poisson. It's a little softer. And also VSM, but it needs some other stuff that we need to set. So we're just going on with the Poisson, which is pretty good for this thing. But what if we want to have the checkerboard have some color? We have this image compose. And image compose works so that it generates an image that comes from the stuff that is after that. So we have the checkerboard operator And you can see the texture over here. We can set, for example, set RGB levels. Sorry. RGB math. Yes, that's what I'm after. We want to have that Boeing style. We can use C+X, and so we add the red channel to be always at full capacity, and no other channels are affected. So the spotlight could be a little further, so we get a better shade. Right, that's better. Or we can have something that is dynamic. Let's say, for example, we use plasma, which might be quite familiar for you from later demos. Toruses and donuts were quite a 95, and well, actually plasma was at the time quite huge. We have plasma there, but it's stationary, and we need the timer for that to have any kind of effects. We need to either find the correct input, or you can just drag and drop this cable on top of the operator, and you can get the palette of which type of inputs that has, because it has so many. Like time. We're after time, so we have dynamic plasma going on. So there it is. And it's black and white. We can use, again, RGB math, or let's say times. We have, for example, blue shade and so on. We can alter that. Or if I don't want to go with plasma, I can do some, like for example, Wally noise is kind of funky looking, like some disco lights going on. We also have the Z-axis on some three-dimensional effects. So what is happening here is that these spheres or orbs, which would have been stationary, go on blinking. And we can use that to generate stuff that is more shady, like that. So it starts to resemble Voronoi patterns a little. But so we have the one scene right now, and we could still group these. Oh, sorry. Create an area for these, and this is a donut. We could have music, for example. It's demo is pretty dull without any kind of music. And we can add some ready-made music from the library files. There's Right and Basta song. You can drag and drop over here, and you have the audio buffer that is containing the song. So we have an operator that generates audio buffer. I forgot to tell about that, so that audio is also purple. I have to add that to the operator cable tutorial patch. So we need output to have any audio at all, and we have the web audio output for that, but still we don't get any sound. And the problem is that there's nothing to take advantage of the source of the audio buffer. And for that, we need the audio buffer player. So we have the sound there, but for a demo, we need to get that synced so that it starts on the proper place and time. Now it's not connected. So we stop that, and we have, for example, timeline controls. Is a patch that outputs play and stop status and time from the timeline. You take the play stop and drag it onto audio buffer player start stop, and time to the offset. So now when you start the timeline, sound is always in sync. And if you go to another place or another point in time, we have the scene and the music in the right place. And for example, we could make the entire room rotate with transform. That is connected to the timer. That would be cool. We would have our first scene ready somehow. And we also have to remember to set the proper speed for the timer. I think 20 would be good. And we need to remember to sync to the timeline. So when we cycle to the proper time, we see everything happening at the right time. Another thing is that you would like to have is that the donut will be synced to the music. And you need to calculate a little for that. You just divide the BPM, divide 120 with the BPM of the song. And I happen to remember that you have to multiply everything by 1.4 for this song to be in sync. So every timer needs to be multiplied with 1.4. Yeah, that's it. And I guess that the sidebar could be a good thing to have right now. We can have a usable sidebar that you can use while using the canvas. You can set it have some controls like buttons. And whatever the button does is that it sends a trigger. And you can set it to have, for example, to reset the orbit controls. Orbit controls has one input for a trigger that is reset. So whenever you press that button, it also resets the rotation and the transform controls for the orbit controls. We'll set it here so it looks nice. And let's set this position to be a little more. The cable ran off. Yeah. So let's rotate it a little. That looks better. So that's the default view for the demo right now. And if we want to have some other scenes, we need to have a way to send the triggers to only those operators that we want to at that point in time. And because of that, we need to have timed sequence, which is an operator that can control that it would send triggers only to that cable, that trigger that you want to at that point in time. And the first one is a trigger that it will always send. But we would want to have this as the scene 0. So whenever we want to change the sequence or the scene, we just change this value. But we need to have that connected to the timeline so we can select the scene that we want in the right time. And for that, we need to have that automated or animated from the timeline. So whenever a variable has those stacked 3 dots in the right-hand corner, you can just click it and assign a variable which we don't know yet, or set it animated. And we just created a keyframe to the timeline that is defining the scene. And we go to a certain point in music that we want to change the scene. So 350 would be a good point in time to change the scene. So we add a new keyframe to 1. And this looks a little stupid because it has a linear slope for that, which isn't that usable for scene selection. And unfortunately, you can't fade between scenes with these because it just gets rounded down like floor to the lower value. So I would like to just change the type of the keyframe. You can access the parameters from this clock sign. So you see the keyframes. And so far we have the animated ports, which is the time sequence. And we can use the switch the easings to be absolute. So this looks more intuitive. So we see that during this time it's a sequence 0, and then on the sequence 1. And we can move these keyframes if we want to, but I'm not doing right now, because we need to create the scene 2 or scene 1. And first of all, we're going to move all of this stuff that is doing the scene 0 into a sub-patch. And we do that by painting all over it and creating a sub-patch. And now, as you can see, it created a new sub-patch that has only that stuff, plus a patch input and a patch output. So you can have values that, or parameters that you can get from the main scene or the top level scene to this scene or patch, and then return some variables or values. And just let's move it so that it's more intuitive. And now we have that. And let's create the scene. I forgot to rename that to scene 0. Now it's more convenient. And we can create the other scene by just, let's say, sorry, not mainly, but sequence. And let's have a cube there. We paint over these two, and all again create a sub-patch. And we have that as the scene 1. So everything that happens there is in the scene 1. And when we go there, we see the cube, which is just looking like a square because it's in front of the camera. We set, for example, the Lambert material, and we want to have some interaction between that. We can add some input stuff. Let's demonstrate that. For example, if we have this music over here, it would be handy to have some stuff coming out from the music that alters the demo, the stuff in the demo. We can have the audio analyzer that extracts fast Fourier transform and RMS and volume and lots of stuff from the sound. But you see that it needs a trigger input. It doesn't work without that one. So we can draw it from the main loop. It makes the patch a little more messy, but we just have to deal with that. So now we have the audio analyzer going on. We keep the music going on. We see that there is, let's click on that. There is some FFT stuff coming out, and waveform arrays, and all kinds of funky stuff. And also the volume, that is pretty valuable for stuff that I do quite often. For example, we can take the average volume and pull it over to the scene 1. And you can create a new port. So now we have an additional input port for the scene 1. And we have the volume coming over here. We could set, for example, the scale to be coming out from the music. So, like that. Let's just rotate the cube a little so that it looks a little better. It's not so front-facing. Like that. Or you can use it to alter the texture as well, and so on. It's sometimes a little irritating that when the music isn't running, you don't see the object. You can see the gizmo over here that is showing the three-dimensional guidelines, but it'd be handy to add just a little to that. Some, let's say that it's at minimum it's 0.1 size, so it's still visible, but it has some dynamic going on. Let's move stuff away because we want to have some more stuff going on. For example, if we want to have some retro-looking line arrays, could use line arrays of really funky-looking operator, but by default, it doesn't look all that funky. The problem is that it's too small. It could be bigger. Now we see the lines, and we could have a separate texture that is manipulating it. We always again use the image compose, but now we're not generating a texture for the material. I just forgot the material. Let's use basic material for that. So we have the color. We have the lines there, but they're stationary. We create a new image. Let's say using like plasma. It's living. Where's the time there? Sync to the timeline. And now we have the plasma going on. We'll set it to manual size, and right here we have the plasma. But what to do with that? One handy way is to use a vertex displacement map. But first, I'll rotate the line array to be on the ground, because you're going to see what I'm going to do with that. Let's add the vertex displacement map, which is an operator that just wobbles or manipulates the meshes that are after that. Let's just drag and drop the image compose texture to the vertex displacement map's input texture. And we don't see, well, there's something to see, but not what I intended to, because that is on the wrong transform. Let's set it there. The lines are still stationary. We alter this a little so that it would be the operator for the vertex displacement map, and it's going to the y-axis, and it's starting to look what I'm after. Still not quite there. We want to increment the number of the columns and the rows, and now it's starting to look more like an effect. Let's still add the material there. Could use basic material and select the color for that. Have red floor. Let's move the cube a little higher so that it's above that floor. So we have some effects going on, and we still haven't animated stuff, and we could do a lot more stuff with the sidebar. Let's start with the sidebar. We could add a slider. And we can use it to, for example, send values to the scene 1. Let's create a new port there. And let's say that it's cube Z value, and let's set the controls to be from -10 to +10 with a step or the increment of 0.1. So those set the minimum and maximum values and so on. And we go there. We see that there's a new input. We can use that to transform the cube on Z-axis. It's sometimes handy if you want to check things, how they go, if you need to change them every now and then, and you don't need to find that specific operator in all of this mess around here. And also, let's rename that button because it's quite unintuitive. Like it's reset orbit controls or reset orbit. Oh, sorry. The text like here. And another handy thing we could do is to create a button to rewind the music, for example. And you see that it generates also a press trigger. We can set that to timeline rewind. It gets a little messy, but here we go. We have it connected to timeline rewind, and let's check if it works. Yeah, it works. So we can get to the beginning if we want. Let's just rename it. Yeah, here we go. And we're about halfway there. We still have an hour left. What else could we do? And we could still see how the timeline works when you animate stuff. Like let's forget that we're moving the cube from the transform slider. Let's set the cube to be animated. And again, let's go to the start of the scene. Here we go, on the 350. Let's check, for example, the X, and we set it animated. And now we see the first keyframe over here. Let's set that it starts from outside of the view, like it goes all the way around there, so you don't see the cube. And stop there. Let's add a new keyframe. You just can do that by entering values over here or clicking the plus over there. Let's set it to 0. So now we have... I think that I need to reset orbit. Yeah. This scene needs camera because it's not in the proper place. We have a camera that we can add, and we can move that camera to be above that level, so you don't need to transform all the stuff. You just move the camera, and it wouldn't be moving any lines that you have attached to that or spoil anything else. So now we have the camera over here. Let's move it a little more diagonally there. Let's hide the sidebar. Yeah. You have the moving cube, but it looks a little dull because it's moving linearly. We can again set the keyframe interpolation or easing to be, like, for example, sine. Let's zoom in so you can see it better. Or you can use cubic or quart or quint or exponential or backwards or glasstic, so you can get the bounce effect. And I think that the bounce effect could be good. Yeah, that looks good. So what else could we do? We still have some time. One thing that we have to battle with is that when we're loading a demo, let's save this. At first, we have the cables workshop. Oh, crap. Cables workshop, test, and we have it saved. And let's reload that. Or let's view it how how the user sees that. I forgot to save that. Yeah. That's how user sees that. And there's no music because a recent change in the browser guideline is that it needs to have some user interaction for the audio to work. But the problem is that now the audio and video are not in sync. And that's a little tricky thing for demos. And one way to circumvent that is that we could not this one, but here we can add a play button. So it's in the center. But let's not use it there. Let's disconnect it. Whenever you want to disconnect an operator, you can just shake it off or hit the X key. And now we have the play button on top. Let's try it that way and see how it happens. Let's reload. The thing is that it's running on the background, but when you hit the play, the music starts. But it's still not in sync. And you can do so that whenever the play button is clicked, you can do the timeline rewind. And let's try how that works. So now the demo starts at the correct time, and you hear the sound. But it's still a little stupid that you can see the demo running on the background before you hit that. And there are several ways of trying to circumvent that. And I've already designed some workarounds there. And I have some prototype demos. Whenever you're starting to write your own demos, you can use them with a play button or so that they have the autoplay, but you need to click the unmute. But let's start with the play button example that I have done over here. It's already quite far. This is the autoplay, and this is with the play button. Let's see how it works. There would have been a loading sequence animation, but it was so quick to load at this network, so you didn't see that. And whenever it's full screen, let's see how it goes. No, not this, but F11, no, F11, no. There you go, full screen. So if you want to record or show this demo, you just have this, and when you click that, wherever you go, you have that playing. Or you could just also hit the space. And how this works is that there's a lot of chemistry, and we have the loading status that has this loader scene that we didn't pretty much see. This isn't that important, but it has the play button connected to an if-true-then operator, and this is pretty deep stuff. You might not understand what happens there. But trigger1's operator is an operator just does one trigger and then does nothing. And we do this because all of the sub-scenes are better to be rendered once when the demo is starting or whenever the patch is opened, so that whenever you switch to another scene, there's not a delay for loading all the stuff. And we have an if-true-then operator that gets the status that if play button has been played, and then it will forever send a trigger to reset the trigger once. So whenever we hit the play button, you see that it sent that. Now I've paused the timeline. Let's reopen that and see how it works. Send that one signal, and now if true then is triggering the trigger once forever, and the demo is running. And the other one is an auto-playing one, so you don't need to hit anything, just unmute that. And there is a certain delay so that it doesn't start right off the bat before you have a chance to hit the unmute button. And it's a little better to have the demo start with the black background and being silent at first if you use this autoplay. And how this works is that it also uses the loading status, and pre-renderer is this time the one that is sending a clear color to hide things when it's loading, and when it's done, it's setting a delay trigger of 1.5 seconds to the timeline pay. And we also have the sound that's usable over here. So if we use these patches to start your demo, you can just remove everything that's over here. You just have the basic kind of dragons over here, and you don't need to be taking care of them. But if you, let's have them back. But if you, for example, want to replace this with your own music, let's see if I have something usable here, like one zine. Yeah, I think this is a usable piece of music. You get that in your private patch files that are connected to this specific patch. And we drag and drop that to the scene. We have the new audio buffer. And here you go. You have the new sound, and let's check if it works. Yeah, we have the new music going on. And that's it. But if you want to create your own demo, you could just create the time sequence if you want to have them at different sequences, and you remember what we did there. And that's pretty much it. And when you're creating some demos from this workshop, let's open this one. You can do them together if you want to do some cooperation. When you go to the patch settings, you can see collaboration. You can see which users can edit or view this patch if it's private patch. And you can send invitation to, like, for example, Pandora, which is the order, but don't send it to him. And you can also generate a secret URL so that people who open this URL can see that. Let's open a new private browsing window, your incognito, and go there, and you notice that you're not logged in, and you can see that patch running on. And whenever you submit a demo to the compo, which is later tomorrow, the deadline is tomorrow, you have 1 day left to create your own demo if you're just loading it right now on the go. And just send that private secret URL to the compo system in the Partyman, and you're all set. And regarding the guidelines, if you don't have your own music, it's safe to, or actually, you're regulated to use free music that is, for example, CC0 licensed music. It needs to be free so that you're able to use it for the compo. Just understand that. And those are the most important stuff that I need to cover here. You could also have some 3D objects that you have made, for example, in Blender going on here. Let's replace that cube over there. We don't want a cube. We want to have something that is really 3D and funky. We have some objects ready made over here. These models. If we should have a teapot or a bunny. Let's set a bunny. Yeah, now you have the bunny. Let's say a little bigger so that we see how the bunny looks. Just remove the rotation. Yeah, that's not like it. Let's set a little rotation for the bunny. No, that wasn't set it. And we can use the LFO again to make it rotate a little. Like, let's say have a wide range. Let's increment it a little. We can use the face for that. We would want to use, for example, 1/4. That looks more like it. You can use the font materials usually. Whites are flexible. Then set the color here. Knife diffuse and phenol, so it's the transparent, to feel less shiny and so on. Like that. And one thing that I forgot to show is how to do post-processing. We can check the tutorial over here from my patches. You can anytime you want, you can open the tutorial patches over here when you're creating a new one. But I have one that is a little better explained, like here. If you want to do post-processing on top of 3D elements, you have a first 3D stuff, 3D space that is going over here. You have a render to texture operator on top of everything. So what this does is that it renders everything as a two-dimensional texture. You get that. And also the texture depth that can be used for some effects operators like the fog or something like that, when you need to know how far a specific pixel is. And then we have the compositing effects. But what is might be a difficult concept to understand is that on top of everything is a rectangle that is stretched all over the full screen window or the canvas. We have that, and we get the texture from the previous image compose. Like, you see that is the stuff coming from image compose. It's going there, and it goes to the full screen. Without that, we would have nothing, but we're replacing this pipeline so that it does a diversion to go to the effects pipeline, and they get then again drawn on to the full screen. So we have a set of effects over here, like edge detection. It does, let's disable these. It detects the edges of any kind of shapes over there. Let's remove that. Then we have the color multiplier. It multiplies everything on top of that with a specific color, and you can change that. And then the mirror, which just does a basic mirroring of a two-dimensional image. And let's disable that one. And then the chromatic aberration, which might not be visible unless you have the canvas quite big. Let's set the edge detection back so it's more visible. If we disable that, it's sharper. You have the chromatic aberration so that it spreads different wavelengths of light further. Like that, you get the RGB separated a little. But what is weird is that you can adjust the amount to go above 1. You can go all the way over 9,000. And you can get some funky effects from that. But also, you can try, for example, barrel distortion. You can get some really weird stuff with that. When you go to negative values, let's remove that edge detect or set it to a lesser amount. Yeah, that's better. You get that pinch kind of effect. And when you go really far, you can get some funky stuff going on. It's not that clearly shaped anymore, not that distinct. And when you go to large amounts, you get some really freaky stuff as well. This is without the noise anymore. Yeah. So if we want to try to create some post-processing effects over here on top of this scene, which is, yeah, was scene 1. We have everything going on here. We add a new sequence. So we're on top of that. Just a little more room. Everything 3D stuff is going down this pipe. And we have the rendered texture. So everything disappeared because this operator is taking the signal out. We have the full screen rectangle down here. You see the blank screen because it's a rectangle with no material at all. And we add somewhere around here, we could add the image compose. And what we do after that is that we have the draw image operator. What that does is that it draws an image into a composition. So we have the texture over here. We had another operator that draws an image that has the texture from this render to texture operator. So you can see over here we have the scene that was missing a while ago, or still missing. And you can do this trick and you get it back again. But now you can add any kind of post-processing effects like blur. That's too much blur. But let's just find just the right amount. And then you can do, for example, another draw image. No, that's not the right one. Another draw image. And let's do that render to texture again on top of that. But let's set the blending mode to, for example, screen. And a little less blur. I think that might be. Get the blowing bunny there. We want to see without the effects. There we go. I think that the blur isn't that distinct. We could use zoom blur. And what you see is happening is that everything from the center is moving towards the edges of the screen. We could use, for example, levels to make it appear a little brighter. Let's set the in-max number to be less. So what we're doing is that we have the minimum input levels, midpoint, in-max. We're setting that the levels of 0.205 is the maximum input level of light, and everything beyond that is going to be clipped at the maximum level as well. So we're raising the threshold, and now when we combine that to the draw image, which I seem to have, no, it's there. I just accidentally disconnected that. Now we have it, the zoom added to that, without and with the effects. We could go even further than that, like that, so we have screech now. And we can even move the center of that, so that could be synced to the music as well. And let's add another scene because we have still some time. Let's add another scene. Let's say to contain some cubes or someone, and no. Create a subpatch again and rename it to scene 2. There you go. And forgot to update the time sequence again. Yeah, there you go. 520 might be a good place to change the sequence. I just need to find it. There, it's time sequence. I'm missing the time, but there it went. It's missing the cursor for some reason, but we have the new value over here. Let's set 2, and we have the new scene over there. Yeah, now we have the scene 2. And I wouldn't like to have a cube. Let's have something more original. Let's have the head to have some uncanny valley. So now we have the GLT of scene head. And for example, if you want to create stuff with Blender that you want to use in cables, you need to have that in GLB format. You can export that, and you can just include everything you want, and you get the scene, which you can show the structure of here. You can have several different objects in the scene, several materials, and you can assign different materials per the object material. But we're not going that far because we don't have enough time. So we have the head, but not material. Let's see what kind of material we have over here. You can let's use just Phong material this time. Yeah, now you see it's a head. And let's create a cluster. No. Random cluster. Random cluster is a handy operator that multiplies objects that you have. You don't need to create an array for that. But let's set it a little smaller so we can see what's happening there now. I have to scale the object a little smaller. Yeah, now it's more working. We have the random cluster. Now we have a set of heads. And we can let them have some, let's change the number. You can have 1, 2, whichever number you want to. You can have the size of the group, the horizontal scale, the vertical scale, and the depth scale. But what is interesting is that you can rotate them. And those rotations are quite random per instance as well. So you can, for example, connect a timer. to the rotation, like that. Let's just sync to the timeline, so it's more trustable. And let's add another timer with a slightly different speed. And it's controlling the other rotation. It's a little too fast. That's like 1.15, like that. And we can again get the volume from the music. It's in the audio analyzer, but it's a little tricky or clumsy to always pull a cable to each one of them. You can use variables for that. And how that works is that I take a cable and I use a var set number. And that creates a new variable or sets the value of a variable. But we have the error that no variable has been selected. There are no variables in the patch, but we can create a new variable. Let's say it's volume. And whenever we're in any of the scenes, we can, for example, set random clusters size to be precisely that number by assigning it to a variable and selecting the volume. So now that's automated and you have less cables going through on all over the place. But the problem is that it's directly linked to that variable. If you want to alter it a little, you can get whenever we want a var get number, get the variable, get the error message, and you can get the volume variable, and you can set that to the size. And let's use a map range this time. Map range is a really handy util that you can use to control if you don't have those kind of variables, they're not in the range you want, and you want to tweak them a little. And you know that the volume is between 1 and 0, like over here. It's the input range that it's expecting. And you can set those to have new ranges, so that is a minimum like 0.1, and the new maximum is like 4, 5, let's say. It's too much. Let's say 2. We can set the easing to be smoother. It's not that visible over here, but for example, if we're setting it to have another input, we could use the easing to remove the linearity to be more smooth. So we can use that timer to also, let's say, transform here. Let's rotate this one. But we need a new timer. This, say 45, for example. Sync to the timeline again. Now we have a little scene. We could use some other stuff as well, like doing background. And we can create that with image tempos again, like have some noise. And we're having another rectangle. That's behind all of this stuff. We just need to rotate that. Set it to be bigger. And we need the material for that again. We ran out of music. We have the noise, and we can use, for example, example, blur, which could be directional, like vertical. And we can use, for example, the volume also here, the amount. We can again set the map range so you can have more valuable numbers. And let's set bottom threshold. Better the other way. Yeah. Yeah. So now we have a demo that lasts for about 15 seconds, I guess. It's not that long, but we have something. And you know the idea how things could work. And the thing with the random cluster is, if you look at cable that goes along, there's a thicker or more dense pipeline going there compared to before that, because it multiplies the stuff that is going there. So if it's like 10 or 1, it's more dense, the more there is data connected to that. So, does anyone have any questions on what to do, or if you didn't understand something that I just went through? Or do you have any ideas on what to create?
Okay. Could you show some camera animation tricks?
Yeah.
Like what would be useful in a demo?
That's a tricky one. We can. Let's switch over to the scene 1, and we have the camera over there. If I'm not mistaken. Yeah. Let's move this time frame there so we have more time in this scene. We have the camera which has a wide set of options that you can use, like IX and IY. Let's see, for example, like that. You have the center, and I think that the center is that what the camera is pointing at. So it's pointing at the center of the scene, but we can set it in the center of the scene, and we can look in other direction. It just needs to be other than 0. It works a little weird way, but and you have the truck, and boom, and dolly. So these first 6 parameters set that how the camera is rotated, so like which direction it is facing. You can move the camera horizontally and vertically, depth-wise. You can also alter it a little by adjusting the tilt and pan and rolling. For example, we could get the volume again, but we don't have it in this scene. We need the var get number. Let's set it to control the camera's roll. But yeah, I forgot to set. But I need to multiply that. just let's reset all that we did here. We could use map range for that. We could use let's say an LFO with the high frequency. Let's say like a 100 could be good. Take the timeline. Let's set the output to the map range value. This should be disconnected. And we set this to the LFO's amplitude, but multiplied by 90. Wrong. Oh yeah, we're on the wrong thing. That's a little too binary. Yeah, we need to remove that map range. That's a little too extreme. I think that I managed to set the orbit again. Less multiplication, let's say 10. Now we have that shading by volume. Set a little less. And we could set the camera's all of the parameters to be animated, like truck, high truck if you're watching this, and set animated so that it goes by time to reach the correct position. Something wasn't right. I wonder what did I screw up. Yeah, I just need to move it more. This timeline is so irritating if you want to do anything with that. I guess I just need to stretch it to get the access to that. Yeah. Yeah, now you see how the linearity is a little irritating. We can set it to be where is it? The sine. Sine looks a little silly that way. You can use it that way. It's too much time going on. Let's move it earlier. Yeah. Still so slow. Like that. So did that satisfy your question?
Yeah, this was awesome. Thank you.
Yeah. It's still a little irritating that if you have a camera that has several values. I lost the camera, it's over there. No, this one. Accidentally pull it to the wrong place. It has these different values, and the problem is that you can't see all of them in the same timeliner. You just have to browse through them. For example, if you set this animated, and I have all these different keyframes and different timelines over here. it would be handy to see and control all of them. For example, if I want to adjust these keyframes to be happening later and all of the coordinates have to be moved manually. That's a little deficiency that Cables has. Okay, so any other questions? And anyway, I'm going to be publishing all of these stuff that I have over here, all of the prototypes with Autoplay, in vitro, output types. I'm going to be publishing them in the party man so you can use them. And actually, I forgot that we didn't do exporting. It's not necessary to do that for participating in the competition, but it's handy to know how to do that. If you want to do an executable file, you can do it through GitHub. You need you need an account over there and the permissions, because it uses the freaky engine. But if you just download everything as a zip file, you can have it running on a computer. For example, if Cables would go bankrupt or all the society would collapse down and you still have that demo file on your computer, you can see that there's all of the files that it contains, the textures and objects and the music. You can download that. And that's downloading. Was it Cables something? And there's one bug considering files that are exported by Cables. If you want to run them on localhost, you get this kind of an error message, like you need to use allow local file access true. You could just upload that to any kind of server outside of your computer and it will work, or you can run a known server on your computer, but you can just edit the index file, go to the end, add a new row, and it was allow local file access. True, and we should be all set. Yeah, it works. So you have this file running on your own computer. It doesn't need Cables at all. And that's it. So this is the basic stuff that you need to know, or it is handy to know if you're participating in the competition. And if you don't have anything else to ask, then I'm just happy to thank you. And we're about to end, but we could check how to publish a patch. If you want to publish something that you have done, you can go there. I think that this isn't yet published. Was it? Yeah, this one isn't published yet. And if we want to publish something, it requires some stuff that you need to write down, like entering some tags there, like prototype and demo scene. Those are enough. And this is prototype for launching a demo with audio visual synchronized and a loader, and it has a play button. And we need to pick a license for that. And I'm using public domain dedication. I don't care whatever you do with this. You don't need to cite me. But if you're publishing your own work, you could use CC attribution, for example, if you want to do some demos that get shown elsewhere, but you still maintain your credit if they want to use that. And I'm gonna publish that, and it's done. So it's public. You can go to the incognito and cables.gl, and one handy way that I didn't show you yet is to explore the gallery to find some stuff that other people have done. It's a good way to learn things. A community, Discord issue tracker, so on. And if we will try to search, the problem is that I'm not logged in, so I'm not able to search for that. But I can copy, what was it there? I can copy this URL. No, it wasn't right. I think this was that. No, I'm lost already. But anyway. Is this? No, I'm lost. This is embarrassing. I have to open my patches again with the play button. Yeah, this one is it. And it should be public. No, it's not yet. I forget to save that. This is a little embarrassing, but we still have time, and I have to do that again. And this is a mistake that you might end up with. Yeah, I think I need to say that again. No, not that one. Here. It should be public. Yeah, now it's public. You just need to remember to save that after you have published it. Yeah. Now that prototype is public and you can view it. And copy and edit it, and that's it. So thanks for listening. We're about to end and get out of time, and this was mostly the stuff that I was about to show you. Thanks for listening and watching, and enjoy the rest of the Assembly Summer 2022.